Okay, I'm on the top of page 10 in our packets, and I'm going to be talking about normal distribution. Now, before I talk about this, we have to understand what a mean is and what a standard deviation is. So let's say my mean, my average, is 10. So if my average is 10 and I have a standard deviation of 3, that means on average my data set is going to differ either plus 3 from 10, so 13, or minus 3 from 10, so 7. So between 7 and 10 is between one standard deviation of my mean 10. Now, if my standard deviation was 3, I said the plus would be 13, the minus would be 7, so I'm talking about a range of 7 to 13. But what if I had then something 2 standard deviations away? 2 standard deviations away would mean I'm plus 3 plus another 3. So that would be a total of 6 away on either side. So if I start with 10, 2 standard deviations away from 10 would be 6. And so 10 plus 16 gives me all the way to 16. If I start with 10 minus 6, so 2 standard deviations away in the other direction would be 10 minus 6 would be 4. So my 2 standard deviations spans from 4 all the way to 16. So let's talk about this. Now, a normal distribution is a statistical data distribution pattern, just like the example that I just talked about, and it's seen with height, blood pressure, lengths of objects produced by machines, a lot in industry. And so the normal distribution curve looks like this below, and we're going to be using this curve a lot. So the bell-shaped curve is known as a normal curve. So the middle of the curve is the mean and the median. So this peak right here of the curve, right in the middle, is the mean. And we know the mean is the same thing as the average. So the shape of the curve is described as bell-shaped, sort of like a little bell here, and it falls off evenly on each side of the mean. So if it's even on the right side as it is on the left side, that means the mean and the median are going to be the same in a normal distribution. Remember, the symbol for standard deviation is a symbol right here, so you'll need to know that. Okay, so on this normal curve, I know this is my mean, and my x-axis right here is the standard deviation. So if I have values that are exactly on my mean, that means I have a standard deviation of 0. Nothing is changing. I have no plus or minus. There's no variance. However, if I go one standard deviation out, either plus or minus, then my percents, these percents are probability percents. So the probability that my numbers are going to be plus or minus 1 standard deviation away from the mean are shown in the chart. So we can tell from -1 to 1, so that's 1 standard deviation, I'm going to have 15 plus 19.1 plus 19.1 plus 15 gives me a total of 68% probability that my number will fall between one distribution of the mean. Now let's talk about 2 standard deviations from the mean. So 2 standard deviations of the mean would be plus or minus 2. So that means I'm going to add up all of these percentages that are plus or minus 2. So 4.4 plus 9.2 plus 15 plus 19.1 plus 19.1 plus 15 plus 9.2 plus 4.4. All those added up give us 95%. And then 3 standard deviations away from the mean is going to be all of these percentages added up that we see here that make up 99.7%. So in my example before, let's say my mean was 10, my standard deviation was 3. If I'm 3 standard deviations away from 10, so that's 10 plus 3, plus 3 plus another 3. So that means if my mean is 10, something that's above 19% is highly unlikely. In fact, only 0.3% likely. All right. We'll talk about, this page is just notes that you guys can refer to as we go along through the examples. I'm going to skip to the examples on page 12. Now, we can only use these values on the normal distribution if somewhere in the problem they talk about normally distributed. So it's very common for something to say normally distributed. So when we see these words, then we can use the normal distribution standard deviation chart on the previous page. So find the percentage of normally distributed data that lies within 2 standard deviations of the mean. So what I'm going to do, looking at my chart, I'm going to add up all the percentages between -2 and 2. So all of these percentages. That will be the probability of lying between 2 standard deviations, plus or minus. So I'm going to add them up. Let's see if I can add correctly this time. 4.4% plus 9.2 plus 15.0 plus 19.1 plus 19.1 plus 15.0. Check my work, guys. So when I add all these up, I get 95.4% as a probability that I'm going to have a number between 2 standard deviations of my mean. So that means not 1 standard deviation, but we're doubling. There's it's very highly likely that your number will fall between that. Okay, number 2. At the New Age Information Corporation, the ages of all new employees hired during the last 5 years is normally distributed. Within this curve, 95.4% of the ages are between 24.6 and 37.4. So here's my curve. Here are my 2 values that they're between, and 95.4% are in here. Now it says find the mean age and the standard deviation. Well, I know that the right side is evenly distributed with the left side. So if I want to find in between 37.4 and 26.4, I can add them up and divide by 2. I can find the average here. So the mean is, remember the mean is my center line here, x. So to get that, I'm going to average the 2 numbers on either side. So adding that up, dividing by 2, I get 31 years. So that means this x value here is equal to 31, smack in the middle. Okay, that's one of our answers. Now I want the standard deviation of the data. So in question number 1, I said that 95.4% was within 2 standard deviations. So that means from 31 to 37.4, there's 2 standard deviations. Well, if I want to find 1 standard deviation, which is in the middle, I can subtract these 2. So find this difference and then divide by 2. So I'm going to subtract the 37.4 minus 31, and I get 6.4. But this is equal to 2 standard deviations. And I want 1 standard deviation. So I'm going to take 6.4 divided by 2, which is equal to 3.2 years. And this is equal to my 1 standard deviation. Okay, and for number 3, the amount of time that Carlos plays video games is normally distributed. Carlos plays on average means the mean, of 15 hours per week. So that's why on this graph here, my middle line is 15. So now I want to figure out the standard deviation of 3 hours. So the standard deviation, they say, is plus or minus 3 hours. So that means 15 plus 3 is going to be 18. 15 minus 3 is going to be 12. So if I'm talking 15 to 18, that's one standard deviation. So going back to my standard deviation chart, that's going to give me a probability of 19.1% plus 15%, which gives me 0.1% probability that he will play video games between 15, and 18 hours a week.